some shueda and train new lesson the thinking lesson area of triangle nang se ginane Heron's formula the mutuni dokche and Thomas de la Heron's formula apply che ne equilateral triangle ki area yang loga dokse ge dus ngajo kuduche and dik jela niya question answer kashi ji ngajo kuduche na sam question answer dige anya exele yung dengi ki question ka chikta ya peculiar question ne yorwa lobde question shi shaw kyangja me beton base digal sha and sabe the CBSE ki yikse nal tegar dawai ko did nyambunga discuss che and Thomas de la equilateral triangle ki area based on Heron's formula ki digal base nga logach discuss che and cheza tango triangle equilateral triangle it's a equilateral triangle ABC equilateral triangle is a triangle ke side sama chikpa yorwa so let us say side dige rindu a ni a la the a can be any unit a unit it could be 8 centimeter 8 a meter okay so direct ne Heron's formula ki area dekhane che hoye area is equal to S into S minus A into S minus B into S minus C whole square root where S is equal to semi-perimeter so A plus B plus C divided by 2 okay so in this case equilateral triangle dinal using this formula let's derive the formula for finding the area of equilateral triangle so here S is equal to A plus A divided by 2 that is 3A divided by 2 S teacher so area of equilateral triangle is equal to using this formula Heron's formula S what is the value of S S is 3A upon 2 into S 3A upon 2 minus A is one length of one of the side of equilateral triangle so in this case it's A the gap that's showing that so again 3A upon 2 minus A again 3A upon 2 minus A now in this case A, B and C all are equal okay now in order to simplify the terms inside the bracket we make sure that the denominators are same so here denominator is 2 so we'll try to make common denominator so multiplying the denominator and numerator by 2 so you will have 2A upon 2 2A upon 2 which is same as A whole square root so the 3A upon 2 now in this case common denominator so 3A minus 2A 3A minus 2A the kharche A sum ne any thena A chikhairwa so A so same chasan chikbar so A upon 2 A upon 2 whole square root so that is 3A into A into A into A that dinala 8 power khazuda A into A into A into A power shichazwa so we can write it A square into A square into 3 upon 2 की power sheet has 2 into 2 into 2 into 2. We can write it as 2 square into 2 square whole root. So there, if we simplify the radical, square and root will cancel, square and root will cancel. Similarly, square and root cancel. Tangi de ngazuchita maths in a sign a numerical problem solve chidu ngazu the nang make thon du chigda square the root cancel, square the root cancel chebane koya tak tada de karzina this root, the common root chazan keep god chaza the cancel cheba the yield sha anga to stay the cancel cheb, right? So a into a upon 2 into 2 root 2 the rangja deswa. So a into a square, 2 into 2 2s are 4. So this can be written as square root of 3 upon 4 a dengan sudah separation constant ke sama nilati variable dengan JLT and the. So this is the formula, the direct formula to find the area of an equilateral triangle if one of the side is given. Now the base the kawasha is a Heron's formula then the base shad one you do derive chezwa. Okay, now we shall take one example. So equilateral triangle, suppose in this equilateral triangle let us say A is equal to 18 centimeter. So here A is equal to 18 centimeter. So S will be equal to 18 plus 18 plus 18 plus 18, 18 sum divided by 2, or you can write it as 18 multiplied by 3. This is a repeated addition. So divided by 2. 2 ones are 2, 2 nines are 18, 9 threes are 27. So the 27 as well. So now area is equal to, use this formula direct, square root of 3 upon 4 into, what is the value of A? It's 18 square, 18 into 18, you'll have 18 square centimeter. Now in this case, S so dinal S mindwa. So area is equal directly square root of 4 into A square. So in this case, A is 18 square, 18 into 18. So you'll get 2 2s are 4, 2 9s are 18, 2 1s are 2, 2 9s are 18, 9 9s are 81 square root of 3 square centimeters. So this is the area of equilateral triangle. Now the second problem is find the area of a triangle whose sides are 8 centimeter and 11 centimeter. Its perimeter is 32 centimeter. So dinala use square root of 30 is equal to 5.48. So dinga and then you understand square root of 30 the question nala le yimba tenkevre. Maybe they use tingmara use square root of 30 is equal to 5.48 and tingmarawa. So here in this triangle, let's say let A is equal to 8 centimeter, B is equal to 11 centimeter. Now C is not given. C in C dilela the perimeter. The perimeter is sum of all the sides. So 32 now C delera. So C is equal to perimeter 32 centimeter minus 8 centimeter minus 11 centimeter. So this 32 8 and 11 19 32 minus 19. So 12 minus 9 3, so 13. So C is 13 centimeter. Okay, now let us find the S. So S is equal to A plus B plus C. There two markers. Perimeter is directly given. So S perimeter is 32. So S is equal to perimeter divided by 2. Centimeter is equal to 16 centimeter. So now area is equal to, in the examination, exact color formula T the by Kitchenbure. Then this was the formula T in that. So S into S minus A into S minus B into S minus C whole square root. So S is 16 into 16 minus A is 8 into S 16 minus B is 11 into S is 16 minus C. C is 13, right? So this is 16 into 16 minus 8 is 8 into 16 minus 11 is 5 into 16 minus 13 is 3. So dinala we multiply all of them, find the product and then find the square root. D tabje chigre D tabje chevena karyorza multiply cheni tuzujik thewata. Dine square root segarodo yang tuzujik thewarudo tuzuni. And if it is not a perfect square procedure, the best way is the prime factorization cheda. Prime factorization chede yang test some that's not what dinala when square root perfect square you perfect square koran nal sharja kora expression means prime factorization machine. For example, in this case 16 is a perfect square of 4. So instead of 16 16 gisabla 2 into 2 into 2 into 2 sheet machi sharja do stentigwa. Similarly 8 is 2 into 2 into 2. You can write it as 2 square into 2. These are prime number factor tayo marwa. So the square and root cancel, square and root cancel. In calculation this cancel tawen ani yang zuki wrong information later. Those cancel tawen cancel check down ki mewa chadu ra nganzo calculation sama true. The yelasha dd cancel che. Chebina the cancel channel 4 has 2 and chanda diga rangja deswa 2 5s are 10 10 3s are 30 the question nala square root of 30 value tedwa tanga the square root 30 takda leswa the question at the goal gimza yor. Okay, so 4 2s are 8 into, now we use the value of square root of 30. Square root of 30 is 5.48. So this is square centimeter. So we shall multiply 5.48 by 8. 8 8s are 64. 8 4s are 32 plus 6 38. 8 5s are 40 43. Decimal point jale digit dwa. So this is equal to 43.84 square centimeter. That is the area of this given triangle. Okay, the third question. The sides of a triangular park are in the ratio 3:5:7 and perimeter is 300 meter. find its area and the length of perpendicular drawn on the biggest side. Side ratio ki kangla perpendicular tijo diki length sela. Question del part ni doa. Okay. So first let's draw the approximate diagram of the triangle park. Let's say A, B, C. So dinane we are given the perimeter, that is sum of all the sides. It's 300 meter, and the ratio of the sides of all the sides. Side summing ratio the 3:5:7. So that means tumu khazol dando 3 plus 5 plus 7. 15 parts. 15 parts nane smallest part the side has 3 parts. Middle one 5 parts. The biggest one 7 parts. So side saying the one by one. Sides are the first one. First 3 upon khazore total khazone divide chongarwa into 300 meter. First one. Second one is 5 upon 15 into 300 meter. And the last one is 7 upon 15 into 300 meter. So 15 ones are, 15 twos are, 0 is 0. So 15 1, 15 20s are 300. 15 1, 15 20s are. So, or therefore, let's say side ABC. A is equal to 3 into 20, 60 meter. B is equal to 5 into 20, 100 meter. And C is equal to 7 into 20, 140 meter. Okay. S is equal to, S is given 300. You have it 300 divided by 2. You can directly write it as 150. So the area of the triangular park is equal to S into S minus A into S minus B into S minus C whole square root. That is the Heron's formula. So S is 150 into 150 minus A is 60 into 150 minus B is equal to 100 into S 150 minus 140 whole square root. Okay, so this is 150 into 150 minus 60 is 90 into 150 minus 100 is 50 into 150 minus 140 is 10. Now, as I said earlier, dinala square you are most do you know. For example, 150 different factorization chaza madam. What we can do is 150 can be written as 3 into 50. Can say quick pair chick 50 chick daily so a square chick into 90 90 can be written as 9 into 10. 10 the pair chick they doing 9 kora perfect square so 9 can be written as 3 into 3 into 10. 50 factorize mata lega thewa guys ko the pair takda pair sodu dwa into 10 the pair sodu dwa cheza the 10 kisalo 2 into 5 jan lega thewa. So you will get that is square you get the square check rua the square check rua. Okay, the square check rua square you get sang machilo matenda 50 into 3 into 10. And then I'll carry square root of 3 equal as a 3 equal as a square root of 3. So did 50 into 3, 150 into 10, 1,500 into square root of 3 square meters. So that is the area of this given triangle. Now the question is, second part of the question. Question is second part, like find its area. Area rather was the second part the color was the length of perpendicular drawn on the bigger side. So in this case, side sum dita the ringsho di diradwas ringsho di ina di ringsho di kazura 140 meter shazwa 140 meter. Let us say this is the second one. The second one is 100 meter, and the last is 60 meters. So that means the angle opposite to the bigger side is angle A. So from angle A, draw a line perpendicular to the base or the biggest side. So let's say AD. Right? Okay. Now AD length this here. So AD length here, what we do? Earlier in the lesson, we discussed Pythagoras theorem. So we can apply Pythagoras theorem, or in another way, the better one is, since we got the area, we can find the area of a triangle in two different ways. By using the Heron's formula or by using the simple formula that we learned in lower classes. Area of a triangle is equal to half base into height. So area is equal to half into base into height. So in this case, we got the area 1,500 square root of 3 is equal to a half base perpendicular to the, in this case base is BC, into height is the one that we want to find, AD. So 1,500 square root of 3 is equal to half into BC is 140 into AD is the one we have, let's say H. So 2 ones are 2, 270 is 140. So they took here 1,500 square root of 3 multiplications side division side division divide by 70 is equal to H. 0 and 0 cancel. So therefore the required perpendicular length of perpendicular drawn from the bigger side H is equal to 150 square root of 3 divided by 7 meters. So that is the answer to the second part of the question. Okay, now the fourth question is, two sides of a parallelogram are 10 centimeter and 7 centimeter. One of its diagonals is 13 centimeter. So find the area of this parallelogram. So for this, let's draw an approximate diagram of the given parallelogram. Okay, now a parallelogram is a quadrilateral in which opposite sides are equal and parallel. So let's name it A, B, C, D. Two sides are given, two unequal sides. So let's say AB is 10 centimeter and BC is 7 centimeter. So since opposite sides are equal, so CD is also equal to 10 centimeter and AD is also equal to 7 centimeter. Okay, and then they have given the diagonal. Let's say that given diagonal is AC. So AC is 13 centimeter. Okay, now normally in lower classes, I think in class 7 we studied the formula of area of a parallelogram. Area of a parallelogram is equal to base into height. Now here height is not given, so what we do, we shall use the concept of triangle. It is divided into two congruent triangle. We find the area of one triangle, then multiply by 2. So that will be the area of the given parallelogram. Okay, so here let's say area of triangle ABC. So in this, let's identify the three sides. Let's say let the first side be 10 centimeter, second B is equal to 7 centimeter, and C is equal to 13 centimeter. Right? Semi-perimeter, sum of all the sides. 10 plus 7 plus 13 divided by 2. 20, 30. 30 divided by 2 is equal to 15 centimeter. Actually, we have to write 10 centimeter plus 7 centimeter plus 13 centimeter divided by 2 is equal to 30 centimeter divided by 2 is equal to 15 centimeter. We have to write the unit clearly. So let's to save time, we'll write the correct unit at the end. Okay. So area is equal to area of triangle ABC is equal to, first write the here's formula, S into S minus A into S minus B into S minus C. So what is the value of S? 15 into 15 minus A, 10 into 15 minus B is 7 into 15 minus C is 13 whole square root. So this is 15 into 15 minus 10 is 5 into 15 minus 7 is 8 into 15 minus 13 is 2. So 15 can be written as 3 into 5 into 5. 8 can be written as 2 into 2. 2 square into 2 into 2. So this can be better together, becomes 2 square. 5 into 5 can be written as 5 square. Whole square root. So this is 5 square into 2 square into 2 square. So cancel the square and the root, right? So 5 into 2 into 2 comes out of the square root or out of the radical. So what is left? Square root of 3. 5 2s are 10, 10 2s are 20. 20 square root of 3 square centimeter. In case in the examination, if you are given the value of square root of 3, then you can put the value of square. Normally, square root of 3 is given as 1.73, or sometimes they will give the approximate value, that is square root of 3 is equal to 1.7. Okay. Now the fifth question is, find the area of a quadrilateral ABCD in which AB is equal to 3 centimeter, BC is equal to 4 centimeter, CD is equal to 5 centimeter, DA is equal to AC is equal to 5 centimeter, and take the value of square root of 3 is equal to 1.7. So that means if you look carefully at the question, you will find that 3 sides are equal. CD is equal to DA is equal to AC. So first what we'll do, we'll draw the approximate diagram of this quadrilateral ABCD. Okay, so here what do you do? Let's say AB is 3 centimeter, and then BC is 4 centimeter. Right, let's join AC, which is going to be the diagonal of quadrilateral ABCD, and then you'll find CD. D is somewhere here. So CD is 5 centimeter, and DA is 5 centimeter, AC is 5 centimeter. So AC is 5 centimeter. So what we can conclude that triangle on this side, triangle ACD is going to be an equilateral triangle. So let's say this is the approximate. 5 centimeter, 5 centimeter. Now, quadrilateral ABCD, you'll find it's an interesting question. Is made in such a way that it tests a number of small concepts. So the first one is, you'll find that it is divided into 2 triangles, and clearly we'll find that one of the triangle, that is triangle ACD, is an equilateral triangle. So without using Hero's formula, the long formula, we can use the short formula. Area of equilateral triangle is equal to square root of 3 upon 4 a square, which is actually derived from Hero's formula. And the second one, let's see, look at this one. 3 sides are given. So what do? We will try to find the relationship among these 3 sides. Let's square all the 3 sides. If you square all the 3 sides, what you will find? 3 squared plus 4 squared. 3 3s are 9 plus 4 4s are 16. And then the square root of the longest side, 5 square. 5 5s are 25. 16 plus 9 is 25. So we'll find that actually triangle ABC is a right triangle, because it satisfies the property of a right triangle. That is, in a right triangle, the square of the longest side, hypotenuse, is equal to sum of the squares of other 2 sides. Okay, so angle opposite to the longest side, angle in this case is B, will be equal to 90 degrees. So therefore, triangle ABC is a right triangle or right angled triangle. If it is a right angled triangle, then out of the 2 smaller sides, one will be the base, the other will be automatically the height. So though the question seems to be tricky, but if you analyze the question carefully, you'll find that this question is a very interesting case. So we'll find the area of these 2 triangles separately. First, we'll find the area of triangle ABC, which is a right angle triangle. So area of right triangle ABC, which is equal to half base is AB into height is BC. So which is equal to half into AB is 3 centimeter and BC is 4 centimeter. 2 ones are 2, 2 twos are 4, 2 threes are 6. So this is 6 squared centimeter. Okay, so this is the first part. And the second part is the second triangle. Area of equilateral triangle ADC, because all the sides are equal. So in this case, let us the side, given side, one of the side is A is equal to 5 centimeters. So therefore area of this triangle is, it's an equilateral triangle, so that is area is equal to square root of 3 upon 4 into A squared, so which is equal to square root of 3 upon 4 into A is equal to 5. So it is 5 into 5 squared centimeter. Okay, so 5 fives are 25 divided by 4 into, you are given the value of square root, a simple value of square root of 3, which is equal to 1.7. So this is squared centimeter. So you multiply 25 and 1.7. 1.7 into 25. 5 sevens are 35. 5 ones are 5 plus 3, 8. 2 sevens are 14. 2 ones are 2, 3. 5, 8, 9, 10, 11, 12. 4 points. So this is 42.5 divided by 4 square centimeter. Okay, we shall divide 42.5 by 4, which is equal to 10.625 square centimeter. Now students, please, you do the actual division. If you divide 42.5 by 4, you will get 10.625. Okay, now the last is, we have to find the area of the whole quadrilateral. So hence area of quadrilateral QAD dot, a short form of quadrilateral ABCD is equal to the sum of these two, 6 square centimeter plus 10.62 square centimeter. Now I will not go into the detail, you just add these two. This is a simple addition, so it comes out 16.625 square centimeter, right? So in this question, it demands two different concepts, the Pythagoras theorem as well as a specific formula to find the area of an equilateral triangle. Okay, now the last question, problem number 6. A villager has a triangular field measuring 70 meter, 240 meter and 250 meter. He donated 1/3 of the field to a children's home which grows vegetables in it. Now the question is, find the area available for growing vegetable. That means you have to find the 1/3 of the area of this triangular field. Okay, now let's draw an approximate diagram. So in this, first we'll draw 70 meter. Okay, let's say 70 meter, and the second one is 240 meter, and join these two. So third one is 250 meter. Let's name this triangle field as triangle ABC. Okay, now you can find the area of this triangle in two different ways. One is according to the lesson. Since we are studying Heron's formula, we shall use the Heron's formula because you are given sum of all length of all the sides. So here let's say let A is equal to 70 meter, B is equal to 240 meter, C is equal to 250 meter, right? Okay, now before that, let's see if you can find a peculiar or a relationship among these sides. Let's check. 70, we shall square all the sides. First, two smaller sides. 70 squared plus 240 squared. We'll see if the sum of these two squares is equal to the square of the longest side. If that is true, then we can say that triangle ABC is a right angle triangle. If it is a right triangle, and then we can use the normal, a simple area of formula to find the triangle, that is base into height, instead of finding the long formula of Heron's formula. Okay, so let's check. 70 square, 7 sevens are 49. When you square, you double the zeros. So this is 4,900 plus here also, since the ending digit is 0, we shall write through 0. Square 24. The short way of squaring 24 is square the units digit. 4 4s are 16, carry 1. And then square these two digits. 2 4s are 8, then double it. 8 2s are 16 plus 1, 17. Carry 1, square the digit in the tens place. 2 2s are 4 plus 1, 5. So this is 576. So that is square root of 240 square. 240 is 57,600. So let's add 57600 plus 4900. So 0 0, 6 plus 9 15, carry 1, 8 plus 4 2, carry 1 6. So that is equal to 625, 62500. Okay, now let's square 250 square. 250 square, since the ending digit is 0, we shall write 2 zeros. Square of 25, like 4 two-digit numbers ending with 5. The quick way of finding the square is square the ending digit 5. 5 5s are 25. And then multiply the digit in the tens place with its successor. Successor of 2 is 3. So 2 3s are 6. So square of 25 is equal to 625. Now if you directly multiply, you will also get 625. So 625. So which means sum of the squares of two smaller sides is equal to the square of the longest side. So from that we can conclude triangle ABC is a right angle triangle because it satisfies the Pythagoras theorem, that is square of the hypotenuse is equal to sum of the squares of other two sides. So therefore triangle ABC is a right triangle. So if it is a right triangle, instead of using the formula, we can use the simple formula, that is half base into height. So area of triangle ABC is equal to half base, let us say base is BC into height is AB. So which is equal to half into BC is 240 into AB is 70 square meter. So 2 ones are 2, 2 ones are 2, 2 twos are 4, 2 zeros are 0. So 120 into 70. So 0, 0, 7 twos are 14, 8. So area, the area of the whole triangular field is 8,400 square meter. The actual question is, you have to find the area of the field required for growing vegetable. So hence required area for growing the vegetable is 1/3 of this. So 1/3 into 8,400 square meter. So 2 ones are 2. 3 ones are 3. 3 twos are 6, 2, 24. 3 8s are 24, 0, 0. So that is equal to 2,800 square meters. So that is the required area for growing vegetables. Now the last concluding part for your work, I have found the area of triangle ABC using half base into height, using the concept of right angle triangle. Now you can try the Heron's formula, you'll get the same result, but if you do it this way, you will save time. And in the examination, if the question demands use Heron's formula, then you have to use Heron's formula. Otherwise, you can use any method available to you. Thank you so much.